Hello class, this is going to be a help video for lab number 3, which is on earthquakes. This is the first help video that I'm making. The previous two labs were relatively easy, so I didn't actually make one for them. But here we go. So I'm going to hopefully guide you through the most difficult parts of the lab. Not every single question, but guide you through most of them, especially those that require you to measure things or figure out things based on the information that I give you, the graphs that I give you. So onward we go. All right, so for the first 3 questions, as you're seeing here in the instructions, you gotta click this link, and then that will take you to an information sheet from the USGS about the science of earthquakes. Once you do that, that will basically run through, or you will be able to answer questions 1 through 3 without much of a hassle. So I'll skip through that in the meantime. Okay. Question number 4 says, in the image below, which is titled figure 0.02, you will see 3 seismograms for 3 different seismic stations. One is in Hawaii, one is in Alaska, and then the third one is in Chile. So you're going to use these 3 seismographs to estimate the SP interval. SP stands for secondary primary wave time interval for each of the recording stations. You're going to later on, after you do this, record your measurement for the SP interval in the table that is below, this one right here, for each of those seismograms. So how are you going to do this? Hopefully it's fairly straightforward, especially after having seen lecture, but just as a refresher, I'll help you through with one of them. So what I'm asking you to do is, again, record your measurement of the SP interval, meaning the difference in time between the secondary wave arrival and the primary wave arrival time, right? So as you can see in these seismograms, the first wave arrival is the primary arrival, and then the second big one over here that tends to be even larger amplitudes is going to be the secondary wave arrival. So you have to determine what the number of minutes between secondary and primary wave arrival is. So from your table, the first location that you should be recording is Hawaii. So I'm going to help you throughout the lab with the Hawaii measurements, okay? So let's do that. Okay, so this is that same graph where I have the 3 seismograms recorded. And what we're going to do in order to determine the SP wave arrival difference is going to be locate both the primary wave arrival time. So as you're seeing, what I'm doing here is dragging the arrival time of the primary wave to the number of minutes that have passed by. So this is 1 minute, 2 minutes, 3 minutes, 4 minutes, so on and so forth. So as you can see, the first wave, or the primary wave, arrived at about 4.4 minutes, right? Not quite at 4.5, but about 4.4 minutes. So I'm going to put this as 4.4. It's very important that you use decimal numbers here, okay? So make sure that you don't use like 4 minutes and 25 seconds. Use decimals for the minutes, okay? All right, and then the secondary wave arrived at, let's see, so this is about the secondary wave, maybe, at about 8.2, right? So if this is 8, this is 8.5, this is 9, so it arrived at about 8.2 minutes. Again, using decimal points rather than minutes and seconds. Okay, so we have those 2. So now, in order to determine the difference in time between the secondary wave arrival and the primary one, we say 8.2 minutes minus 4.4 minutes gives us, so hopefully you can do this in your head, but if you can't, you can use a calculator. This is 3.8 minutes. So that will be the SP wave arrival difference for Hawaii location. Cool, so 3.8 minutes. So that's what you're going to record on your table right here, okay? And you do the same thing for Anchorage and for Calama, Chile. You do the same process. So you're going to take these and basically measure where this falls, where this falls, where this falls, where this falls, and subtract the minute arrival from either one of those locations. Alright, so examine the graph that you have below, this one right here, a graph of seismic wave travel times. There are 3 curves on this graph, so as you can see there are 3. 1, 2, and 3. The upper curve is the S-wave travel time graphed versus the distance. So travel time here on the y-axis, and then bottom here is distance in kilometers. So the first curve is showing you the S-wave arrival time depending on how far that was felt, basically that wave was arrived. Where was I? Versus the distance. The center one, so this center curve, is the P-wave travel time versus the distance. And then the lower one shows you the variation in distance with difference in SP travel time. So here they're already taking into account the difference between the P-wave and the S-wave arrival times with distance. Okay? All right. So I tell you here a statement. I say it takes an S-wave approximately 70 seconds to travel 300 kilometers. Well, so let's see if that's true. 70 seconds is right here, right? And this is the S-wave. So in theory, if I go down to the distance, yep, that should fall under 300 kilometers. Great, makes sense. And then on question number 5, for practice, I say, how long does it take the P-wave to travel this same distance? So remember, the distance is 300 kilometers, so you want to find that in the x-axis, 300 kilometers, and you want to find your P-wave. So P-wave is the second curve. So then you just go to the y-axis and you find however many seconds that takes for the wave to arrive. Straightforward. Okay, question number 6. Use the following SP graph, so this one that I have right here, and this is based on true measurements for different earthquakes, or one earthquake that had happened over several locations that were measuring it. So you're going to use that graph. And again, SP graph is primary wave minus the secondary wave arrival times versus the distance. And then that estimate, and the estimate, sorry, that you made for the SP time arrivals from table number 1. So whatever you got over here, you're going to use those with the graph paper to determine what the distances are from the epicenter for those 3 locations. So again, I'm going to help you with the first one, which is for Hawaii. So ideally, now we already have this area filled up, the SP intervals. So here we know that in Hawaii it was 3.8 minutes. And we're going to be able to figure out what the epicentral distance is. So let's see. So this is the SP graph paper, right? And we know that the arrival time difference between S and primary wave for Hawaii was 3.8 minutes. So as you can see, this is 3 minutes, this is 4 minutes. Each of these lines is an increment of 0.2 minutes. So if I go 1, 2, 3, and 4, that's an increment of 0.8 minutes. So I want 3.8 minutes. I draw it all the way up to the line, or to the curve, I should say. Once it hits the curve, I'm able to find where that lies in terms of distance from in the x-axis. And as we're seeing, this falls in about, let's see, this is 2,000 and this is 3,000. And there are 5 increments, so 1,000 total kilometers divided into 5 is 200. So each of these increments is 200 kilometers. So 2,000, 2,200, 2,400. So the distance from the epicenter of the earthquake that Hawaii is at is going to be 2,400 kilometers. So that's what you're going to record in your table right here, 2,400 kilometers. Again, using that SP graph. So you're going to use the values that you obtained from table 1 that are now going to be expressed here to determine the epicenter distance for Anchorage, Alaska, and for Calama, Chile as well. All right? Again, using the same graph. Good. Okay. Question number 7. using the distances that you obtained in the last question and the locations for each recording station, use triangulation in the world map provided at the end of this lab, which is figure 0.06, or sorry, 0.6. So in order to do this triangulation, I would recommend that you review the lecture and also review the video that I posted under the Lecture 3 module for doing triangulation. So to find, again, triangulation is done to find where the epicenter of the earthquakes are. So let me take you to that. So if you go onto Blackboard, under the lecture part of the class, so remember that not the lab one, but the lecture one, you're going to find topic modules. Under topic modules, go to week 3 on chapter 3, which is on earthquakes. If you go a little bit further down, you'll be able to find this link right here, how to locate an earthquake. So click on that link, and that will take you to this video, which shows you how to use triangulation to locate an earthquake. So I'm gonna sort of show you little snippets of it, and hopefully you watch it before you continue on with my video. So pause this video and watch this one that I am showing you on the screen in order to continue onward. Okay, so I'm going to help you again with the first one, with the Hawaii location, and then you will do the other 2 locations to finish the triangulation and actually finding the epicenter of said earthquake. Once you find the epicenter of said earthquake, you're going to scan that resulting graph or take a very legible picture of it and upload that picture as a file response on the Blackboard quiz. Okay? So let's go do that. So if this is our map, right, that's the map that I provide to you at the bottom of the lab, we have to find, first of all, the location of Hawaii. So the table says that Hawaii is at 22 degrees north and 158 degrees west. So thankfully the map has coordinates. So we say, okay, this is 0 from south to north. I want 22 north. This is 15, this is 30, so 22 lies about halfway. So somewhere within here, right? And then I know that I want 158 to the west, okay? Or was it 58? I think so. Yeah. So, let's see. So I have 180 is pretty much the middle of it. Typically, positive numbers are going to be east and negative numbers are going to be west, okay? So I want 158. So this is 165 and this is 150. So 158 lies quite in between them. So this is where I want this section, and I wanted this section for the north-south direction. So Hawaii is just those set of islands right there. Honolulu is in the Oahu, which is kind of the middle one. So there you go. So that's our location for Hawaii. That's the first step on triangulation. Second step is to determine the distance from the epicenter, and that we already figured out using the SP graph paper. So we had figured out from this that because the S and P wave arrival time difference was 3.8 minutes, that the epicenter of that earthquake was 2,400 kilometers from Honolulu, Hawaii. So we already know that that's 2,400. And so here below you have a scale of a total of 4,000 kilometers. I want 2,400. So I already measured that for you as you're, as you're seeing there below. So this is about 2,400. So that is the radius that I want to use for my circle to do the triangulation. And thankfully I have already drawn a circle that has that radius comprised. So I place that in the middle of my circle, that radius, right? And I know that the epicenter, once I do that, I know that the epicenter of the earthquake I'm trying to locate happened somewhere around here, somewhere in the circumference from this circle. So in order to actually find whether it happened here, 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 wherever, you have to find the 2 other circles from Chile and the one from Alaska. And wherever those 3 circles intersect one another, that's the epicenter of the earthquake. And again, you do that by using the information that you obtained in the previous questions. Okay, so I think you can do it. If you can't, again, ask me any questions that you may have, and I'm happy to help you.